So good evening, everyone, and welcome to our Skill Vertex webinar. So before starting the webinar, I would like all of you to fill a form. I'm sending a one form in chat box. Kindly fill it at the end of the webinar. You guys will receive an ebook. So everyone, please fill this form. Okay, so let's get started. So this is our webinar, popularly known as Skill Connect, a series of well-designed and engaging webinars organized by Skill Vertex on knowledge imparting topics and industry trends. So the topic for today's webinar is advanced data analysis with Python. Okay. So before we get started, I would like to take a moment to introduce myself. I'll be going to be your host for today's session. So I'll be getting you through a brief overview of what we will be covering in today's webinar. So in the next few minutes, you will be getting a brief introduction about the topic that we will be covering in today's webinar. And this will help you to get a better understanding of what to expect from today's session and prepare you for the insights that will be shared by our mentor. So we have a very special guest joining us today, and I am honored to introduce you to our mentor, Mr. Rakesh Raj Purohit. He is a highly experienced data science specialist and with a 7+ years of experience. He has worked in many highly reputed companies, including Bosch Global Software Technology, and has achieved great success in helping individuals and organizations reach their full potential. So throughout the webinar, he will be sharing his knowledge and expertise. Okay. So we are very fortunate to have him with us today. And I encourage all of you to take advantage of this unique opportunity to learn from one of the best in the business. So please join me in giving a warm welcome to our mentor, Mr. Rakesh Raj Purohit. So this is also a great opportunity for you all to take advantage of this unique opportunity to learn from one of the best. So but before we dive into the topic, I would like to take a few minutes, to break the ice and get to know each other. So please feel free to introduce yourselves in the chat box and let us know where are you joining from. Okay, so let's see who all are interested to introduce themselves. After that, we will start. No one is interested. I guess you all are more curious about the webinar. Okay, so we will move forward. So now, let's, we are an edtech companies. So we designs and manufactures industrial level upskilling courses for freshers and working professionals in multiple domains, such as engineering, finance, marketing, and management. We provide live as well as recorded sessions. So with our platform, you will have access to a wide range of courses that are designed to meet the needs of today's fast-paced and ever-changing job market. So whether you are looking to learn a new skill or improve your existing knowledge, we have something for everyone. So one of the key benefits of our platform is the flexibility it offers. You can learn at your own pace and at a time that is convenient for you. So our courses are designed to be self-paced, which means you can complete them whenever you have time. In addition, we have a team of experienced mentors who are always available to provide guidance and support whenever you need it. Our mentors are expert in their respective fields. It will help you gain a deeper understanding of the topics covered in the courses. And another great feature of our platform is the interactive learning experience it offers. So our courses are designed to be engaging and interactive. So which means you will have opportunities to interact with other learners and share your knowledge and experiences with them. We also have, we also offer various certifications upon completion of our courses. So it will help you to enhance your resume, and stand out from the crowd in today's competitive job market. And the best part is that our courses are affordable and accessible to everyone, because we believe that everyone should have access to high quality education regardless of their background or financial situation. So if you are looking to upskill or reskill yourself, or if you are just interested in learning something new, I encourage you to check out our platform and see what we have to offer. In the end of the webinar, I'm going to show you our website and platform and how user friendly it is. You won't be disappointed, trust me. So thank you for taking the time to learn more about our company and platform. Now let's get back to the webinar and learn from our mentor about advanced data analysis with Python. So let's get started. So welcome, Mr. Rakesh.
Hi Harsh, thank you so much for your introduction, and I'm very privileged to take this webinar today. Uh, um, it's a good evening to everyone who have joined, and thank you for joining today's class. I think definitely I will be going through the data analysis with Python today. As Harsh mentioned, I also want to know your background
Get
and
started.
few information about all the attendees. So it's best meanwhile if you guys can write in chat what is your about introduction and just brief information about you, what is your background. So that will also help me out to conduct a webinar more in detailed manner, that what kind of background and how should I go over. So again, thank you everyone for joining, uh, and I will be sharing my screen and I will be going over the presentation. So I hope everyone able to see my screen.
Yes, it's visible, Rakesh.
Okay. Uh, so hi everyone. So in today's class, we are basically going through advanced data analysis with Python. And what we are going to cover in this webinar is basically we just introduce what is a data analysis itself, and how do we can do the data analysis part, like different steps are followed in the data analysis process. There is a structure to follow when you're doing a data analysis part. It's not a random or you can't do each step in different way. So we have to follow a process and steps to do a data analysis. We will go over those steps and how do we conduct to make a meaningful data analysis over there. And then we are going through the about the data analysis tools or toolbox which are available with Python. Like few of them are pandas, matplotlib, scikit-learn, and seaborn, and scipy, numpy, and those all. So we'll go over these in a brief about that, and then we'll go over that one of the use case, which is like housing price prediction, and we'll see that with this data, how do we come up with the results, and the how do we select the data which is useful, and how do we come to a conclusion about insights and understand about that. So that's overall about today's agenda. So let's go over to the next topic. So I have divided into the three part here. So first part is about data analysis introduction and types. Second is data analysis toolbox, and third is the use case about housing price prediction, which we are going to do that. Okay. So so let's come first to the what is data analysis. Okay, so data analysis is basically in many of the business and many of the data, data is mostly in the raw forms, which may not be directly usable. Okay, so many times when we do the data analysis, so it's many time it feels like we are not able to conduct, the data is not useful. So to get an insight about the business information, we need to do a lot of process about that. And by the definition, if you are going through the overall data analysis, the process of cleaning, transforming, and processing this raw data and extracting actionable relevant information or insight. So what we can do, if we have consider an example, I have a data about a retail domain, okay, and there is a sales, and there is a consider for an example, um, a store which sells fruits and in the mass market in India, like okay, I'm not taking any name, but you can consider for one of the example of retail stores, which retail chain, which across India, and you have a different kind of a products are going sales through, and you may not know what exactly the SKUs are there, and different kind of products are getting sold out. So the data may not be in that form because the data is collected in different way, like when one distributor comes, they may send data in a different type, the other distributor will send the data a different way. So then what exactly we do is we may need to find out which is the most selling product, which is the most demanded product, which is the most like you can say top 10 products which are getting sold, top 10 most profitable products, and different kind of a actionable insight you can see. So if there is a something most demanded and we are under supply, we have to see that, we have to understand this data and go through it. So basically the data analysis is making this business informed decisions, because we have to make a decision. We can't make all the decisions on the gut feeling or some view way. So we have to do that in a manner. uh, okay, so to do that, we may need to clean this data, transform this data into one form where all the data comes to a single view, and then we process this data, and we may do various type of visualization analysis over top of that, and come to a conclusion and make a decision. Maybe we do correlation, we covariance and co-analysis. The lot of kind of different kind of analysis we do to perform that. Now giving to you a motive about why Python is important for data analysis, because you may ask, there are various tools are there, R, SQL, C++, so various tools there, but why the Python is we should understand and read about Python. And I'm going to tell you that there's a survey is conducted within the data analytics community, and they have asked a question that which is the top programming language when you are doing your data analysis. So overall, what the results are coming is, you can see here. So 83% of the survey participants have taken Python into the top programming which they going to use. Okay, so you can see the significant difference between other programming languages or other query language or any other language. You can see Python is 83% survey candidates have taken that. We use Python as a very on a regular basis and very important tool. 44% SQL, 36% R, and C++, Java, JavaScript, they are very minimal. These languages, JavaScript, Python, may be used for POC, showing the results, but mostly what you see in the Python and SQL, they are the most fundamental language when you're going for the data analysis in today. Maybe previously people used to use the Excel views and over that, but nowadays the Excel is gone. You can see that not much people are using Excel or VB, like VB language. You can see here Visual Basic is only 7% for now. That previously going to use, the most of the people are going to use VB and R. So now it's very important that you learn, if you are going to into the field of either data analysis, data science, or AI. So most of the environment or world around this is about Python. So it's a very important you guys to learn analysis in Python programming. So I think I have given some motivation to do about that, to learn Python for data analysis. So let's go over to the next topic now. Next topic is data analysis types. So there are different type of data analysis when in a generic way. In generic way, when we are doing data analysis, there's a different kind of, like, one is a descriptive, diagnostic, predictive, and prescriptive. So when you're going about descriptive, what exactly you look is what happened. So in this, what happened is, like, you have a historical data and you want to see that why is this you consider an example of Google Analytics. Google Analytics, I mean, is when any retail shop is there, there are many users come, put the review, they write this one, and they may click on something or not. So there are a lot of, or maybe you're ranking the data on the search results. There you have the results are coming up. So you may see that what kind of search query they write. Okay, and then what the process they follow when they click on search this query, search this term, and then go to the, like, you can say that fresh fruits near me. So when they do the search, what exactly happened, how many times your impressions are coming. So you exactly see what exactly happening there, and how many people's visited there, what they search. So it's all about, like, uh, in a manner is a descriptive. It's descriptive in sense what search terms have been used, how many visited. So it more about what you can say is, uh, it's going about the historical descriptive, like, you can think in this manner is many times how we write a history. When we write about in the history book, what we write is, this happened, this happened, this happened, this happened. On this date, this happened. On this particular, this many people came, this many things happened. So it's more about descriptive information that we gather from the descriptive type of data analysis. Now coming to the next data analysis type, that is diagnostic. In the diagnostic, what exactly happened is we basically see uh, that why did it happen? Like consider the same the data analytics for Google Analytics example. Like you have a website, you have a click and you have search term, people are going coming to that. So maybe you will see that there is a drop in people which are coming in a month. Like January, there are 80,000 are coming to your site. Clicks are there and people are coming to that site. But maybe in the next month there is a significant drop, 20% drop is there. So you want to understand why exactly this happened. So what exactly you do is basically you will start identifying the additional sources and data. You will see the correlation, understand why it may happen. So there's a maybe there's other variables, maybe the search term or Google search are not coming to that. So your pricing strategy, you maybe the sponsored ads are there before but not now. So there's a lot of other variables which might affect your results. So in the diagnostic, you will analyze that which particular uh, variables are affecting my overall results. So one more example, you can think about the sales as well. When you're doing a sales, there are many components to a sale. Maybe product marketing, maybe product pitch, product is as well, product packaging, product branding. A lot of other things are there. If the sales is decreasing, there may be some reason which you have changed, or also there is a other external variables also, because there is a some information are there, like if there's a COVID, the COVID situation come up. So there may be an external variable which affects your sales or information. So you diagnostic, you do the correlation or analysis on your final output, that see that why did it happen, why my sales is decreased over a time. Is there any I can do to help out this? So that's the second type of data analysis. Now coming to the third type of a data analysis, which is predictive. So in the predictive, what exactly we do? We analyze the diagnostic and then we'll see that uh, which variable, how should I use those variables, and see that consider for the example, the same example which we are going through, the sales only. So in the predictive way, we see that if my number of customers acquisitions are increasing day by day, so how much will be the my sales? If my potential the infrastructure resources are increasing, how much my sales will increase? So basically based on those all variables, we try to predict in the future sales or future data. So overall, you can see the predictive. What we do is we try to predict the future based on our certain understanding about the past, and learning from the past variables or historical data. And we basically model this data and see that what can be the projection for the future. Okay, so that will be covered in the data analysis of prediction types. Okay, now coming back to the next type is the prescriptive. The prescriptive is very much it's you can say domain specific, and many times it's very granular details. It requires a lot of more than data analysis or Python type of steps. You may require a deep understanding of a domain as well in the prescriptive. In the prescriptive, what exactly you do is you basically identify the course of action. You suggest, you recommend that based on for to doing a prescriptive, you have to do other processes like descriptive and diagnostic before giving prescription. So and then we recommend that these kind of a uh, actions you follow. Like please, what you can suggest is prescription one kind of a example. You can say that the same example I have given, the website people are coming. So maybe in the prescription I can say that please increase your Google sponsored ad uh, cost and show it more times. Maybe try the other kind of a channels also, like YouTube, Instagram and other, and try to make those also. And then also you can say that what combination will be the best for you. and you can decide the budget and other information also. And also you can suggest few other information like your product uh, fit or website is not much better on that view. People are dropping out coming to that. The UI is not useful. So these are prescriptive kind of actions are based on the or you can say the based on the data analysis, uh, which is a combination of descriptive, diagnostic, and also the combination of a domain expertise. That's a fourth kind of a data analysis about prescriptive. So any question at this point? If there's no question, we'll proceed further.
If anyone have any question, they can ask in the chat box.
Okay, sure. Um, so let's come to the next topic here. Um, we have gone through the data analysis types, but there is a whenever we are doing a data analysis, we have to follow a process, because otherwise following a steps of process, we may not come to a proper conclusion and results. So in the data analysis, there are a few generic steps are there which we need to follow. And I think it's the best to understand that what all steps are there rather than just jumping to the data and looking into the data and going over, because the data may not be the like previously there is 100 lines or 200 lines are there. Nowadays the data is very vast and huge. So you just can't go over the sheet and look into the data and do those all kind of steps, manual type of work. So you need to follow some kind of a data analysis process and steps to come to a meaningful conclusion or insights about the data analysis. So coming to that data analysis process in the generic way, first what we have to do, doing any kind of a data analysis, first we need to define the question that what exactly our objective, what are we trying to solve here. So if I'm taking a data for a website, and I'm considering that my customer, how many customers are coming to my site and how many are retained there. So I need to define the question first about the data, like what I'm trying to solve here. In a generic sense, it may not be a very minute or detailed level that what exactly in a pinpoint level, but at least you need to write and define the question that what exactly are you looking, because if without any goal or objective, if you are looking at the data, you may not be able to look into the data perfect way. So you need to define your question first, and then you go for the about different kind of a methods to analyze that data. So the first step, an important step, to define the question, your objective, your goal, what exactly are you looking from the data? Okay, and then based on your question, what exactly you do is you collect the data, because may not be all the data available. Whenever just excuse me. So many times when you are defining your question, the data may be available at distributed data sources. The data many times in the business, the data are silos. In silos I mean is the different places the data are. Considering the data silo, I means is, if I'm just considering an example of the same website, people are coming and how what their journey is there. So maybe different view, there's a data from the Google ads, there will be different data from YouTube, Instagram ads, there will be different data. How the people are coming to clicking on those data, there will be a different source of the data. And also I may need to click my product information, UI information. People are clicking on which particular again and again, what path they are follow. That will be in the different data set. And again, there will be a like how many times my data or website will up or down, or there will be load traffic and loads are there. So there is a different kind of a data you need to collect from different resources and different sources basically. So based on what you have defined your question in the previous step, you now collect the data, that all which are required. You list down all the information what you need for this question. And after collecting the data, what exactly you have to do is, when you collected this data, now you have to clean this data, because many times data is not in the form which you can directly apply the any processes. Considering for an example, when you are doing a search terms or text query or anything. So the data will be in like subfolder level, or many times the data in the PDF documents, maybe in the JSON files, or different kind of unstructured way the data can be. The other way is like many times the pricing informations come from the an offline channel. When you are doing a marketing on offline, many times not the marketing is online. Many times you put the posters out, or many times you put the like you can say that pamphlet or something. You can do the marketing out of that also. So you have a cost about that and what kind of area you have suggested. So those all are not into the textual information. May you take a PDF out of it, or maybe the location information, the data will be in a different format. And maybe there is a the values are not present for uh, many of the data sets. So you need to understand which attributes or columns have data, and what we can do to significantly put into the data or value. So you basically need to clean the data, and and you have to process into a form that will be going to the next step for analyzing this data. Okay, understanding this data and going through this. So you need to do that in step 3. And then what we are exactly going to do, that after analyzing data, we'll do the visualization and sharing your findings. And inside we'll see that, yeah, the Google ads are working very great, and the YouTubes are not working better. Nowadays people are moving more on Instagram, Facebook ads are not working, and maybe the pamphlets are not useful. You may need to put an signboard on something. So there's a different kind of a findings and visualization you can do. What exactly over the when you have done this kind of a marketing, how much uh, growth you have seen in, or you can, how much traffic you can see on your website, and different kind of a visualization analysis you can do on top of that. That's a final step. So there's a various way to do visualization and finding. That depends on what is your question, what is your analysis. So the step 5 is very much open to do that. Okay. So after that, let's come to the next topic here. So I hope it's clear to everyone till now. Is there any question here?
You guys can write down your questions and doubts in the chat box.
Okay, no problem. I will move to the next topic now. The next topic is about data analysis tools. So uh, whenever we are doing data analysis tools, I'm just writing a few data analysis tools, because going over all the tools will not be possible in this time period. But I'm just going briefly over these which are most commonly used data analysis tools here. So Jupyter Notebook is mostly many times people use in the data analysis and data science community. There are other editor or tools are there. You can consider from if you are coming from a programming background, you may have seen Visual Studio, PyCharm, and other. So similarly, there's a Jupyter Notebook. It's what exactly it's do is you can run your step by step your commands or your code over there, and you can see the results on that. You can further go, you can read. So many times why Jupyter Notebook is very useful, because in other code editor you need to run the full code again and see, but in this you can run one particular chunk of a code. You can run it and see it, what exactly is happening here. If you see that this particular is not working out, let's see the different way. Like you have done the reshape the data into another form, and you see that the data is not looking according to the requirement. You just again edit and run it again. So you can do it on it's basically help you to minimize your effort also, and do you basically it's reduce the time which you effort which you require to run again and again. So it's more flexible and more convenient to use Jupyter Notebook over there. It's also when you're using Python, you can do simply pip install Jupyter Notebook and it will be installed, and you can it's basically it have its own UI. It's a browser based service, so you can run on your port, local port, and you can use it whenever you are running. It's a very easy to use, and it also allows you to convert or export into the Python file PDF file, HTML file, and it's easily shareable across everyone. Okay, that's about the main when you're looking for that. Now coming to the pandas. Pandas is basically what you can say is many time in the data, when you're doing the you converted data into the data frames. Okay, so the pandas name is basically panel data frames. So you have a different panels for data frames. So in the action, you can see in you can relate it to in this way is, when you have Excel, you have a sheet out there, and in the sheet there are different rows, columns are there. Similarly, in the when you're reading the data, the pandas have a data frame kind of a mechanism where there's a different panels of the data frames are there, where you look into this data, and it's basically allows you to do the lot of data manipulation operations. So pandas have lot of methods and operations which you can easily allow to work on different kind of statics. You can get directly if you do the df.info, you will get the all the information like how many NaN values are there, what kind of data it contains, what are the unique values are there, and many types of a you can say many types of data um, information or data statics are available on the hand. So you can directly use this pandas data frame. And one more example, one more advantage here is a pandas, you can convert it into the any form, the data frame. If the results are there in the row and table form, you can save into the JSON file, you can save into the HTML file, XML file. Different ways are there. You can read also the JSON file, Excel file, and use it as a data frame. So it allows basically to manipulate and get the information or insight about the data more easily. So we can do the manipulation on the operations on the data frame very easily over the pandas. So it's a what I'm saying is this is a very basic and very important kind of a concept. Pandas we are going to use most of the time, and considering that data frame concept is going to be used all over the data analysis and data science, because everything is coming to the data frame point of view. When we are thinking doing any analysis, we have to think from the data frame perspective. We'll go over this in our use case, that how do we are using it and what kind of operations we can do. But just going over briefly over here. Now next is a matplotlib and seaborn. So I'm just going a little faster here because we have to cover the use case also. So matplotlib and seaborn are libraries where we do the visualization and see the results, the bar chart, pie chart, different kind of charts we can build over that. The seaborn is more dynamic and I can say more interactive compared to the matplotlib. Seaborn is also based on the matplotlib, and then there's a scikit-learn. Scikit-learn is basically a tool for machine learning algorithms. So you have a plenty of algorithms are there which you can find and read about that, and you can go over that. And just going over that, there are many kind of a just going over the scikit-learn site. So for you to understand, so what it basically provide. So you can see machine learning in Python is mostly happen with the scikit-learn. So it's a very simple and efficient tool. You can see there is a for classification, there are algorithms for regression clustering. So you can basically import these all libraries and you can use it. So to going through that, you can see one of the any example uh, for classification, regression, or I'm just giving you here an example is to when you are doing, you can go through this and get the more information about this. So ordinal list square, if you have to do, you just can um, take this linear model library and you can fit your data and you can find the coefficient. Okay, so this is basically trying to predict the line, which is making these data points prediction. So there are different kind of algorithms also there. So these like even though if you are learning about the ML also, this is a very great source to learn about ML, machine learning, and data science also when you are doing this. So here this is an example of SVM. You can do the kernel, you can define those all models information. You can fit your data X and Y. X is basically your input data or training data, and Y is your prediction variable. and then you can basically predict your values. Okay, so it's very useful. You can open in the Colab, you can see that how the results are coming up. So I will suggest you to go over this and read about it. So many of the information will be available directly and you can try and play with it. So now coming back to the our use case here. Oh, I hope till now it's clear to everyone, right? So I can also go for pandas just to show you guys an introduction. So these all are like their own website, which they do. Um, these all tools are very easy to install. Going through that pip install pandas, I think you can do that if you're going through the if you know about the Python and everything. It's just a package and libraries are there, and you can install those all very easily. What you have to do is you have to just do pip install pandas. You will be able to do that, and you can see those all uh, Python version and importing all those things. So there's a very great resources out there. If you want to go over in your manual details about that, you can see here pip install pandas, and then what kind of tabular data information. So right now these are open source and the community based, uh, and you can get a lot of other information also. Okay, so the pandas is also based on NumPy and other uh, like SciPy, based on SciPy. Um, So even though you can see the toolkits here, TensorFlow, Keras, PyTorch, these are like high level data science um, tools. TensorFlow is Keras is most used for deep learning kind of a task and projects. So they may not be in the part of data analysis, but it's more about the AI and deep learning part. Um, so matplotlib you can also see here. So from the question or your information, you can see is basically matplotlib is a comprehensive library for creating static, animated, and interactive visualization in Python. So that you can see over our tutorial that how we are going to use it. But you can see here the basic matplotlib. What it do is it takes the x, y, z coordinate and plot according to that. Okay. And the Seaborn is mostly also based on matplotlib, but that's very highly interactive and very much dynamic. So if you have any question, please write on the chat. Um, so I will answer your queries, but if not, I will go into the next topic here. So now coming to the our use case here. So what exactly we do is in this use case is we have a housing data sets which are provided by AMPS housing data set. AMPS housing data set, you can see. So it's AMPS lower housing data set has been provided. It's also known as a Boston housing data. Um, okay, so they have provided this data. You can see this data, the data size is 2930 observations are there, or observation I mean is records are there around 2930, and there is 82 variables are there. Okay, so you can keep it again focus 82 variables are there. If you do manually, you is not possible with the Excel and all kind of things. It's a better prefer to use the Python here because going through these all variables, analyzing one by one may be very cumbersome. Okay, so that's why this data has been taken consideration. Uh, and what is this data content is information from the EMS assessor office used in computing assessed value for individual property. So it's about predicting what will be the price of a property. Defining a lot of variables are there. when people are writing a information about why my house is expensive or what cost for my house will be, there are a lot of things are there, like location, story, particular locality nearby, or how many rooms are there, what kind of a flooring is there, what kind of a design architecture is there. So you can see there are a lot of kind of a variables are there. So it's a very complex data set when you are coming through that. So the data also into a different form also. So here to make a consideration here, the variable description here are mentioning the order is discrete observation numbers. Discrete is observation number 1 2 3 is then there's a nominal. Parcel identification number is a nominal. Numeric, basically nominal is a numerical. 030 020, these all are numerical. And again, nominal joining is nominal is like A, C, F, P. These all values are defined for a particular kind of a classification data. So what here they are giving is the data information. These 82 variables are there. They are different type of data. So first step when you're looking into the any data analysis problem, look into the data first. What kind of variables are there? What all values are there? So you can see here these all values are there. Nominal, again these are nominal. So GRV1 is for gravel, PEV is for paved. So these all are like class. Nominal is basically about classification type of values. The different classes are there. So our category may fall into one of the category. There's an ordinal. So there's a difference between ordinal. Ordinal is basically you define in an order. Data is defined in an order. What you can say in order is the your t-shirt size, uh, small, medium, large. It's an ordinal. Okay, they are not in the same, and also coming like small, big, large. So they are order. Some kind of an order is there. So those kind of a data is considered into the ordinal type of category. So here you can see the gentle slope, moderate slope, and severe slope. So they are ordinal. Gentle slope is very easy. Moderate slope is little higher slope, and severe slope is more higher slope. So and then again nominal is again when we are doing the classification, and ordinal is again uh, the based on the order. Okay, so I think you should look into this form also and what kind of a data. There's a continuous and there's a discrete type of data. So there's a difference between continuous type of data and discrete type of a data. Continuous type of a data have a floating number or real number values. So what you can say is the size of a carpet area is that like it can be 652.5 square feet, or what you can say the total size of the uh, what you can say total super built up area is 1052.5 square feet, or any kind of a values it can be any number between that. uh, so also considering from that perspective, uh, the continuous is there. And then there is a discrete type of a data also. Discrete type of a data have only discrete values. Discrete means 1 2 3 4. So the example for discrete you can see here. Remodel that. Year built. Year built is like 1991, 1992, 1993. Okay, these kind of a data is there. So I hope till now it's clear to everyone. So we have looked into the data description here. Okay, so coming back to the our data, this is about the data. What exactly we are looking is in this data, the question the question which we are trying to solve is we are trying to see or analyzing which all variables are affecting the sale price of a house. So that's our objective, that's our question that we are trying to solve here. So based on that, we have collected this data considering from that. And now coming to the overall analysis steps. So in this session, we are going through the one of the exploratory data analysis. Here, Mhm. Okay. So in this, we are going for exploratory data analysis. Exploratory data analysis, what we exactly do in this step is we do the data exploration. Like we see that what data is there, what exactly the information this data contains, and what kind of a different kind of information we can get from the data. It's like what you can say, it's like exploration of a data. Uh, you can similarly you can visualize in this way. When you are going to a new location, you will try to explore what exactly is there, what kind of different shops are there around, what kind of a different products has been sold there, what kind of a different market is there. So those kind of exploration you do over on your own. So similarly here is the data exploration. In the data exploration, what exactly we do is we explore this data, what kind of attributes are there, what all variables are there, what type of a data it contains, what different unique values it contains, what variables have it have, and what the data has been correlated, and which kind of a data is more frequently used, and what kind of a more dependent data, which are not useful data. If data have a missing values, different kind of exploration of the data we do. So that consider into the exploratory data analysis part. So that's what we are going to do this today. That's one of the I will be covering the EDA today, but what is the overall process when we are problem solving a full problem? So we start with the data exploration, visualizing, find missing, look for correlation, and then we do the data cleaning also, check did I fix the potential issues there with the data like null values, medium values, average values, which are not required columns or which have missing values. The data may not be the right form. So that all considered into the data cleaning part. Then we are doing the model building. In the model building we visualize the results. We run some kind of a models out there like linear regression, logistic regression, different kind of a regression or classification based on the problem statement. Okay, so that you can go over the scikit-learn page. There's a different kind of models are there, and then we do the ROC curves and see that what kind of evaluation criteria we see, that how exactly the accuracy of the results are there, is the results are coming to the right form or not. So that all we do in the model building, and then we present the results. We create charts, graphs, tables, and put into the inside form. That's what exactly we do into uh, the research part of that. We do the recommendation suggestion. So you can think from this data analysis types which we have given. The data exploration can be data diagnostic. Okay, uh, so you can see here in this. So there's a descriptive and diagnostic. Data exploration come into both descriptive and diagnostic also, data exploration. And then there's a model data cleaning is mostly it's a feature engineering and part of the data engineering. So data cleaning is different, but data exploration coming both descriptive and diagnostic. What exactly do what happened and why did it happen? The both things we do in the data exploration part. And then model building is mostly coming into the predictive part, what is likely to happen in the future and what kind of prediction, that we cover in the model building part. And then the present results, so the presenting results coming into the prescriptive part, what exactly we recommend, what exactly the results are there, how we can improve it. So those all will consider into the this part. So so let's first come into the preparation part. So for the preparation, first import the necessary libraries are there, which is required for firstly there's a pandas, seaboard, and matplotlib, which we are importing. You can import uh, pandas as PD. So you can write anything after as, but most conveniently or mostly followed is import pandas as PD, seaborn as SNS, and matplotlib.pyplot as PLT. So these are package in Python. We import in this form. We applied import package name, and that uh, is it. What you can say is a alternative name here when we are doing. So many times you require to run the matplotlib inline because the visualization may not be work on the Jupyter notebook when you not do the inline. So let's run this. With the ls, we can see what all the data or what all the uh, information is. It's basically list out the directory which we are currently working on. In the input, you can see these all data are there. Train.csv, test.csv, data description.txt. So if I run this data, input train.csv, you can see this data. Here what I'm doing is df.head. So here you can write how many rows do you want? 5, 10, 15, how many rows you want to see. Those all information you can get here. So this basically allow us to see a information about the data, what is exactly content, what data looks like. So these all variables are there, these all information it contains. So it gives a view that this have a some kind of a numerical value, this have a categorical value, this have a different. So total number of ways rows are there. So you can see that. But to get more into that about the full information, what you can run is df.info. So one point to note here is here in the pandas, what we are doing, we are using pandas to read CSV file. We have just given the path of the CSV file. It's a CSV file. Pandas is able to read it and convert into the data frame. So this is what it's when we are mentioning about the data frame. This is what the data frame is in the Python or pandas perspective. So when you run the df.info, you basically get all the information about the data, like column, serial number, like ID, have no null count, 460 no null, type is integer, ms subclass have 460 no null, and integer type, and you can see that lot frontage. So that's have a 1201 no null. It's a float type, so it's have a missing values here. So with this information, you can see LA have 91 no null, all other are null values. So for other it the values are not present. So you can see these all information one by one. So these are integer, float, and then there's an object type. Object type can be nominal or string based values. They come into the category of object here. Okay, in Python pandas. Okay, so by this analysis you can see that there are few variables which may not be useful for our analysis because they have very few values and most of the values are missing, like LA and pool QC. You can see LA again here. LA have 91 values only. And pool QC have only 7 values. So they may not be relevant. We can see from here, understand from here that like miscellaneous features and other values are may not be useful because they have most of the data is missing. So we'll first concentrate or focus on the day insights, which will give the real values, and we'll do on that. So what we do here is we'll drop those columns: ID, LA, pool QC, fence, miscellaneous features, so which have very less values. So what exactly we do, we done a logic. If the data have a 30% or less NaN values, we'll drop them. So what we did here is we do totally df column and count. Total values are there. We'll count it. We'll do the length of df. Count is basically count the values which are present. So it will count only non-null values, and length of df will count all the values. So and then what we do, if the percentage or ratio is greater than 0.3, we'll consider it. Otherwise, we'll drop those columns. So those are list of dropped columns. So now let's look into that how the sales price our main objective variable is the sales price, and we'll look into that how exactly the distribution is there for this. Okay, so we'll describe this and we'll see. Firstly, with the description, we can see the total count is 460 values. The mean value for sales prices, 1,80,922. Standard deviation is basically the deviation. Standard deviation is 79,442. Standard deviation is basically with one like what you can consider is um, how much value you can cover. So there's a center limit theorem is there. I think that will be part of this topic, but you can consider is it defining the deviation from the mean value to understand that how much data vary that we can see from this value. Then there's a minimum value is 34,900 house price. 25% of the values are coming into 1,29,975 category. 50% of values are coming into 1,63,000, and 75% top 75% values are about 2,14,081. So that you can see the min or max in between min or maximum value of the price was 7,55,000. Okay, so we can with the simple info with the describe we can see these all information. Now looking into dist plot is basically a distribution plot. We'll see that how the data is distribution over. Here we are using Seaborn SNS to see it. What exactly we are doing with the dist plot is we are defining here the data frame. This is a data frame and this is a column name in the DF. So you can see DF dot columns. So these all columns are there. When we are taking one of the column value, what you can do is like the sale price is there. You can run sale price. Okay. And then you can run like head or something. So you can see those values, sale price values. Okay, so these are like first 10 values are. So this is a way to extract a column value, individual column value when we are doing it. Okay. So that's what we are doing here, and then we are describing it. And then what we are doing for the dist plot, we are giving the series. Basically, it's a type of a series. The values are series type, and then we are doing the color as a green here, and bins is equals to 100. 100 bins we are creating on this histogram, and so you can see here. This is how the data looks like. Let me minimize it to see it in a full view. So you can see from here this now. So overall the data is you can see it's starting from somewhere here, the minimum value. Okay. And then the data is following a pattern. Okay. And then there is a, obviously there is a, these are maximum price, sales price values are there. They are very minimum one after another. So you can see the most of them are distributed in this in this part of the distribution. You can see around 2 lakh. You can consider the 2 lakh is a kind of a mean point, and values are around this. The sales price is around this. So this basically will give you the understanding of data distribution, what all minimum value, maximum values are there, mean values are there. So what exactly you do, you can consider some anomalies, or you can say you can take a analysis criteria that why exactly these values are very high comparative to these distribution of data. So when you are doing a prediction model, you can analyze according to that what was the main reason behind that these price of the house is very high comparatively to these houses, and these houses are why these are very clustered together. So you can form those questions according to your mind and analyze this data. Okay, so that's what you can see here. You can also see the density. So each beans have the different density, 8, 9, 10. How many observations are there? So that's what you can see, that there are few which lies above 5 lakh. Once you want to get rid of them to get a normal distribution of the independent variable and see that how exactly it's working. So let's coming to next is numerical data distribution. So for numerical distribution, we need the data to be converted into a form of a numerical form, because most of the analysis and algorithms work on the numerical values. It's not on the string or nominal values they work. The prediction models or analysis models for these kind of a problems. So we may need to convert those into the numerical form. So those you can see here. So we first identify which all are numerical values. Okay, so these all columns are numerical. So we'll now plot them and we'll see individual distribution. We'll see what is their distribution, individual data. Okay, why exactly we are doing, we'll come to this, but we need to see that what is their distribution there. Now I'm running, each have 50 bins, and one by one with the histogram, I'm plotting a histogram here for each numerical or values. So it may take some time. Okay, I will cover through a little faster here to go through that. So overall, what exactly we do is we just check the distribution here for each one, and we'll see that which are very similar way the distribution is. So the similar way of the distribution uh, from our cells, we have already seen our cells data, and we'll try to see how is this data related to. Okay, so individually you can see this different type of a distribution is lot frontage may look similar to the distribution of cells. They might look in the discrete way very similar. This is very different of years built. So there's a different way. Again, this is a distribution very similar to total BSM SF values. This is again a very similar view. This is again a very similar distribution. So here we can identify which have a very similar kind of a distribution from our sales price with this. So you can see the first half total BSM SF load frontage seems to say similar distribution. So this one, the first half, okay, GR living area, it's very similar. And the next was lot frontage. Lot frontage also you can see is very similar. Lot frontage is very similar. So here we can identify which have a similar distribution over here. Okay. So next what we will do, we'll try to see the correlation over here. Correlation is basically when one value is increasing, how much the other value is increasing. We'll do that analysis to see that how much they are correlated. Okay, and they will do the will identify those features uh, with the sales price which have a more than 0.5 of correlation. Okay, we'll see that correlation here. So when we done the correlation here, we just basically we can do the, this is a data frame, we can run the core method here, and we can done this with the sales price. We'll see the all the correlation here. Okay, so that's very easy to run over the Python df.num correlation. That's all you are able to see, and you can also apply the different kind of a filtering out here. Okay, so then you can see the overall well have a 0.790982 correlation. Then GR live area also 0.70. Garage cars have a 0.64 relation. Garage area have 6.2. Total BSM SF These all are what you can identify here. These are very important variables to predicting the house sales price. So this is give you a very beautiful insight here that which are the correlated variables are there. When you are considering for a sales of a house, you look into the overall quality. So definitely you look into the overall quality, like how it well maintained. So if it is a well maintained, the price will be high. So overall quality factor is a very important. Then the living area size is also very important. If the bigger living area size is there, it's definitely will have a high price. And then there's a garage, cars are there. When the garage and cars options are there, so it will definitely will be priced according to that. So a total square meter or square feet area of the house is also very important part to for a sales price. And then also you can see the uh, what kind of a area or years built in or remote. They also very important factor for a house sales price. So you got a some view here and some insights here. What all factors are important here with analysis. So now we'll plot the numerical features, see which ones have very few or explanatory outliers, and we'll remove the outliers here. Outliers is basically those values which are totally significantly away from the other values, other group of values which are present, which may affect our correlation, and we'll see that. Uh, so I think there's a lot to cover, but I will just go briefly over now. So, so here with this, what we exactly do, we try to see the linear relationship with the operators, which have a more linear relationships. Those variables will consider linear relationship in this way, and we'll consider those values only. So next, what we will do, after seeing the linear relationship, we'll see that uh, which are correlated and which all interesting correlated variable we can consider, like negative correlation, positive correlation with each variable. We'll see and we'll plot those correlation one by one. Okay, so we have seen some strong correlation with few variables, like positive or negative as well, both are fine. So we have identified these all variables with strong correlation, and then we'll see the feature to feature relationship, like each feature what is the relationship between each other, like what is their relation between. So we can plot this kind of a heat map here, and we'll see the more the green values are there, the more they are or yellow are there, they are more related to each other. So you can see each are related to correlated with one with each other, but you can see 0.83 here, years built is 0.83 with other. Okay, so you can see in this way the other variables. So you can see the first floor SF square feet area or total BSM square feet area is very similar. Yeah, definitely the total basement square feet and total first floor square feet will be very similar. They are very correlated. And then we do the these kind of a descriptive analysis, and then we see that which all features are to analyze. So these all features are there to analyze, and we'll go over this. And we'll do again the distribution and see what all categorical and these variables are there. So overall, if you're doing for categorical analysis, you may plot the box plot to see this, and with the box plot, you can see which all uh, variables are correlated with each other and what is their distribution, like top 25%, 35%, 75% values are there, and these are outlier values. So this is very great to find out the outlier values, box plot. So that's all. Again, you can see the bar plot to see the values about the categorical values. So with this, we find out the categorical values, their distribution using the bar plot. So how so it's basically do the counting of the values, how many vinyl C SDs there, how many metal SDs there. So it's basically count of the each type of roof style, how many times gable is there, hip is there. So different kind of a analysis of nominal data we do, and we'll see that predominant for some feature like utilities, heating, garage condition, functional. These all values are very important and maybe important for a sales price consideration. So So that's overall about analysis. So I think we may not be able to cover everything in this uh, in the detail with this webinar because it's a very minimal. It's just an introductory part, and how do we go through this? It's overall giving a brief cover about all these things. Um, and I think we have. I think I have covered all this overall architecture and what exactly we do to do analysis, what kind of tools we use, and how do we use. So the more details may not be possible to cover with this webinar only. But I think you might have understood with this webinar that what kind of a flow or architecture or what kind of steps we follow to do analysis. So definitely, I think that will be very fruitful for you to when you start out. This may be a seed point here to start out your data analysis journey. That's what the main motive for this webinar. So you can just have a seed about those different topics, keywords, and understanding that how do we follow, how do we run and data frame, how do we use it, the different kind of ways we follow. Okay, so I think that's all from my end. So hi Harsh, you can
Hi.
take now.
Okay. Okay, so thank you so much for taking the time to join us today and for sharing your knowledge with our audience. And your contributions have been invaluable, and we are grateful for your guidance. So,
Thank you so much, Harsh. It's my privilege to join today's class, and it's very great to share this all study and information. Thank you all
okay,
for joining.
so before ending this webinar, I would like to take you all through our website, Skillvertex website. So I'm sharing my screen. I hope my screen is visible to you, to all of you. So this is our website, skillvertex.com, and these are our courses. Let me take you through. So these are our mechanical engineering courses, AutoCAD, CATIA ANSYS. We have many other courses like in computer science. These are the options that we provide: machine learning, AI, app development, cybersecurity, data science, and many other. In electronics, we also have courses. You can check out our website. Apart from that, we also have courses into management, various kinds of courses. Plus, the one of the very good things is that we also have a placement assurance program. So into this, we have two courses, that is digital marketing course and full stack development course. So you can go through this. Now, I will show you all our, official app. So let me take you through. So this is our app. So you can have our access to all courses, in your pocket itself. So learning has become more convenient. So this is all we have today. So we will be having more webinars in the future. So you can join. So once again, I would like to thank you for being an amazing mentor and for, being an integral part of this webinar. So we truly appreciate your contributions, and we hope that we have to have the opportunity to work with you again in the future. So, and I would like to thank you all for joining the webinar today. It would have not been possible without you all. So thank you once again. Bye.